Hi there and welcome to another dissection tutorial. I'd like to have a look at the dissection of the frog for those of you that are in grade 9 and who might be doing that this year. So when you first get your frog, you're of course going to wash it off and prepare it for the dissection. First of all, have a look at the external anatomy of the frog and look at the digits and all the parts of the mouth and etc., etc. When you finally are ready to open up the frog, instead of using a scalpel, you're going to be using two pieces of equipment here. The Dissection Forceps or tweezers, you're probably familiar with that name, for pulling the skin. These are very, very helpful. And also the dissection scissors here, which are used to make the incision. Now, this student is making what's called a longitudinal incision because it goes lengthwise along the body of the frog. And it's on the belly or the ventral side, and what you do is you pull up the skin with the forceps down around here. You start pulling it up, and then you insert the sharp end of the scissors under the skin, and you start making your incision, cutting all the way up until you get under the chin region. Now, when you do cut with the scissors, you want to make sure that you use a pulling action like this. Having fun with the pen here. To pull upwards on the skin instead of pushing down, because if you push down you're going to damage the internal organs. So pull up when you do this. Okay, let's move on. Now here's a nice picture showing the kind of things you're going to see when you first open up the frog. There may be a couple of organs moved around and maybe even a couple of things removed. So let's go through and point some of the things out. So first of all, you'll notice that we've got dissection pins here, which are used to hold the skin in place. Okay, so you can use those to open up the frog and get a good view. The major internal organ is right here. I'm tracing that, and that's the liver. And that's responsible for producing digestive enzymes, various substances to help with the breakdown of food. Now, what would be nice if it was visible, but it's not here, I don't think anyhow. Underneath here is a small green sac-like structure called the gallbladder, which holds bile that's made in the liver. It's stored in there, and then it's released into the small intestine to help with the breakdown of fats. So it's possible the gallbladder is just squished there, and maybe I've got it in another shot. So that's the most prominent organ. Another very obvious thing here is this sort of J-shaped organ, which is the stomach. And the food will pass from the mouth down here and underneath through the tube called the esophagus, which would go under there, and then into the stomach, which performs the physical, the churning, and digestion and chemical digestion using various enzymes. The food would then continue from the stomach into this region here, part of the small intestine, and that would coil around in the body cavity. And it looks as if that has been removed for this picture. So we'll have a look at that later. Now, another really nice organ that I want to show you that I often don't get many pictures of is right here. And that's one of the lungs. This would be the left lung. A sac-like structure, very liquidy in a sense here, fills up with air obviously during breathing, and because it's a preserved frog, the lung is deflated. There would be another lung over on the other side as well. Okay, what else can we see in this picture? Well, there's obviously this yellow blob. That's some fat there, used for insulating organs, keeping them warm, helping to position them, keeping them in place, and also used as an energy resource. What else is in here? There's really not too much, so we're going to move on to the next slide. Okay, in this shot we can see again the liver, darkish green, greenish brown structure, largest internal organ. Underneath the liver would be the gallbladder right there, and interestingly enough, now I see in this shot, see this brown thing? Well, that's the lung we were looking at before that was over on this side, and it's sort of been pushed under the stomach there. Here's the stomach, J-shaped structure, and the lung has been pushed over and is sort of poking through. So you get a nice shot of the texture and the sort of the fragility of the lung. Anyhow, again, coming down under here, we do have the stomach, and you can sort of see the musculature here required for crushing food. Now, if you open up a stomach, and I believe I've got a shot of that in a minute, you can slice it open down here. Using the scissors is probably the best bet to cut through it lengthwise, and you may find various bugs and other objects in the stomach. Anyhow, the food would continue along here into this region right here. You can see a small little narrowing or constriction where the stomach ends and the first part of the small intestine begins, and then the food comes along here, travels through, and that would be part of the small intestine right there. And that again would coil underneath, and it looks as if it's been removed in this case. You also will notice this yellow stuff over here. Again, this is called a fat body with these finger-like projections. Now, deep under here we have a coiled tube, and that is called an oviduct. And an oviduct is commonly present in the female. You might be familiar with that term, part of the reproductive system. But it's also present in male frogs, and it becomes non-functional in the male frogs, and perhaps we'll talk about that a bit later. Okay, another view of the abdominal cavity again here, showing the liver up here, broken up sufficiently. The J-shaped stomach, that constriction I was telling you about, so the beginning of the small intestine, and the food will move along the small intestine under here and continue along as it's being broken down and nutrients are being absorbed. And it looks to me like it curves around, and this might actually be a piece of the large intestine right here. Once again, we see the fat bodies, and that's about it. So we'll move on. Okay, in this photograph, I've enhanced this region here because I want to focus on this stuff. So in this shot, you can see, first of all, this is a dissection probe, it looks like. And this is a curved, blunt object that's used to push organs out of the way without damaging them like you would with a scalpel or scissors. So definitely make use of that. And the other thing I really want to point out is this right here. You know, the utilization of your hands. Probably the most important dissection instrument of all is to use your fingers to manipulate things. So here you can see a number of internal organs have been pushed aside so that we can look at the organs that are deeper down in the body cavity, in fact towards the back of the frog along the back body wall. And the thing that I want to point out here is this organ right here, and that is one of the kidneys. And this would be the right kidney because this is the right arm of the frog, right? So this would be the right kidney, and there would be one on the underside, but you really have to dig down in order to see it. This is the organ that filters the blood of the frog and produces urine. Now, you can also see here, and this is very nice that it's in this picture, this structure right here, we've got what looks to be the urinary bladder, which is where the urine from the kidney travels down a tube and enters into this sac-like structure which can swell to store the urine until it is excreted. Now, the other thing I want to point out is this coiled tube, and it's very narrow diameter, and this is what we called the oviduct before. And I admit I'm not an expert on frog anatomy, but because it is a very narrow diameter tube, I'm going to guess, with probably 60% accuracy, that's about it, that this is a male frog, because the oviduct in a female tends to be larger, especially obviously when she's laying eggs or about to lay eggs. It's going to be a larger diameter for the eggs to fit in there. But I think that this is a male, and like I said before, the oviduct in a male is present, but the sperm actually doesn't travel through the oviduct as the egg does in a female. Instead, the sperm travels through little ducts on the side of the kidney. So I wanted to show you that because I think this is a rather nice shot. Let's see what else we got. All right, well, we're in a totally different location here. Can you recognize this? Well, this is the underside of the frog's neck here. This is the sort of the anterior region. We've cut through the breastbone, some of the ribs, and here is the heart sitting in the sac, which is called the pericardial cavity or the pericardium. And there it is. And this is a beautiful shot showing how it is encased in that sac and protected. And there will be some liquid in there to prevent friction as it beats. And the other interesting thing about the frog heart, the amphibian heart, is that it's a 3-chambered heart, unlike our heart, which is 4. And here you can see a nice white ventricle, just a single ventricle. And underneath you would find 2 atria up in that region. So 1, 2, 3. That looks like a nice little face there. 3-chambered heart. What's this organ here? Largest internal organ of the body. This is the liver. And underneath the liver would be the lungs, and down further would be the abdominal organs. So it looks like I've got one more shot to show you here as promised. Internal organs removed and a longitudinal incision made with the scissors, it looks like, through the stomach. And the interesting thing about this shot is that you can see the folds of the inner stomach wall, part muscle and part inner lining tissue. These are called rugae, and they help to increase the surface of the stomach there to help with the churning and with the release of digestive enzymes. So by all means, open up the stomach, remove any bugs, which you will probably find, and examine the rugae. Yep, that's it. So, hope this helped. We'll see you again.